first NIH/RRC workshop on core efficiency. I'm Bill Hendrickson. I'm the president of the ABRF. For those of you who don't know what that is, that's the Association of Biomolecular Resource Facilities. And we're sort of we are the one international organization that covers all types of core facilities. So we're sort of the go-to place, and I think that's why we were very pleased when Jim contacted our leadership and said he wanted to put this on, and thought we would be a good partner to do it. So we welcome you, and Jim will talk more about the actual what we're trying to accomplish here. But I just wanted to let you know that a couple of things. We didn't have a break because we're trying to be as efficient as possible. But you are welcome. We will have coffee starting around 2:30 outside. So if you just, if you need to get up and you can just wander in and out and get a cup of coffee. After the meeting, there is the ABRF annual meeting is going on right now. We're having our workshops, and our opening reception will be this afternoon at 6:30, I think it starts. But you're welcome, if you're still here, if you're not flying out right away, to come to our opening reception. We'll give you a couple of drink tickets, and there'll be some food there. And we can continue the conversations that are started here for anybody that wants to stay. I think we have a good mix of people that are ABRF members and ABRF leadership, along with NIH leadership, and then a number of, quite a few people that are in university leadership that are involved with core facilities. And the ABRF, our mission is core education, research. We have a number of research groups that perform studies that do things like standards. And we're trying to cooperate with government agencies as much as possible. Obviously, NIH is a major one. We're beginning to cooperate with NIST on doing standards. So we feel that education, we give in our meeting that'll be coming up in the next few days, we have sessions on things like specifics of core management. And a lot of people that have a PhD don't really know how to do a budget or other types of management. What do you do with problem customers? What do you do with problem employees? So things like that we can help provide some of those aspects that you don't get in terms of your education as a scientist. So I feel that it's a good synergy because that's what ABRF, in one way or another, the ABRF is all about core efficiency and having cores and core organizations that run efficiently. So with that, I have Jim Anderson come up, and he can give you more details.
Thanks, Bill. I'm Jim Anderson. I'm the NIH Deputy Director for Program Coordination Planning and Strategic Initiatives. We just call it DPCIPSI. I want to thank ABRF leadership, Julie, Auger, and Bill, for being willing to take on this issue with us. It's an extremely important and pressing issue now. So what are we trying to accomplish? It's really clear to all of you that cores are fundamentally important to how we get science done. It's also pretty clear to all of you that NIH has lost 25% of its buying power since 2003, and it's not clear where the budget is headed. So we need to continue to do the best science with what we have. So the issue we're going to take on today is how can we enhance the efficiency of our core facilities and have them support the best science? What's the structure of the day? ABRF leadership asked for an opportunity for NIH to present issues about policies and mechanisms for support. So we will do that with some representative groups from NIH. We'll end that with a panel discussion, and you folks are free to ask whatever you can. If we can't answer now, we'll get back to you. And then the later sessions will have presentations by some institutional leaders, and they've been tasked with thinking about what obstacles did you face in making your core systems or cores more efficient? What can you share with others so everyone can take advantage of your insights? And what's preventing us all from being more efficient? Is it NIH policies, for example? Is it institutional cultures or policies? So I'm going to ask everybody to participate. There's 2 mics here. Everything that's presented here today is being recorded, and we'll produce a written report for the web, for the ABRF website, and I will use that with NIH leadership to present recommendations about what we need to do, what NIH needs to do, and what institutions need to do. As Bill said, there aren't any breaks because we're going to be efficient. There will be moderators here to moderate the question periods. And again, I want to ask you to be both practical but also provocative. If there are things we're not doing that we should be doing because they're just out of the box, let's put them on the table today. Okay, so our first presentation is from the NIH Deputy Director for Extramural Research, Sally Rocky, who unfortunately just couldn't be with us today because of an injury, but she is going to present via WebEx. So if somebody can help me, we can get Sally started.
Okay, I've got my screen up. Can you see it?
We're not seeing you yet, Sally, but we will.
You won't see me. Unfortunately, I had technical difficulties with my video, but you should be able to see my screen. Great. Thank you very much. I very much appreciate this. I want to thank ABRF for hosting us, and I also want to thank Jim Anderson and Deepa Kipsey and OREP, which is the Office of Research Infrastructure, for this opportunity. We've been at this a long time, trying to figure out ways that we can work in partnership with all of you to make our cores as efficient as possible. I'm going to mention a few things that we did a number of years ago with NCRR, which has evolved into OREP. And so we've been at this a while, and we really need all of our thinking together in order to assure that we are most efficiently using our funds on cores. So I'll start with just our definition of a core, which are centralized shared research resources that provide access to instruments, technology, expertise, consultation, and other services to clinical investigators and other investigators. And really, this definition goes on because you should have dedicated personnel, equipment, and space that constitutes the core. There is recovery of costs in most cores, or at least a portion of their costs, in the form of user fee, some sort of user fee. And they can be supported in many ways. They're supported by institutional funds, federal funds, external revenue, or other funding. And here's one of the issues that first raises its head when we think about how cores are supported. When cores are supported by institutional funds and federal funds, and in fact they may be supported by federal funds across a number of federal institutions, then there comes the question of how these core facilities can be shared when there is this commingling of funds by various assorted sources. And I think there's been a lot of urban myths that have developed over the idea of how to share facilities or core facilities when they are jointly funded. So we'll have an opportunity to talk more about that today, and we're going to hear, I know we have some representation from NSF and some other federal agencies in the audience, and we'd really appreciate during our discussion period if we could talk, if there are issues particularly to the sharing among federal agencies when more than one agency supports a core. So, of course, we have a lot of advantages of cores. We provide access to advanced instrumentation and associate management expertise. Really, most of our cores at this point, particularly with the way IT has gone, we can integrate information management and data systems together within cores. And we can provide for centralized oversight, which does enhance efficiencies. And so one of the questions that we're going to be asking today is how centralized oversight works to facilitate cores versus a more distributed oversight of cores. And where a centralized management allows us to do things like consolidate billing and purchasing and scheduling, as opposed to what might be a smaller core, which may have a benefit of having its own management without being part of centralized. So we'll be hearing more about that with some of our examples today, particularly from those of you who are at the universities. So we support cores in many ways, and this is one of the origins of some of the complexity of cores. Of course, we have our P30 Center core grants, but we use all these other activities, and here we go into NIH lingo with all of our activity codes. So you don't really need to pay attention to that, just to know that cores can be supported either individually as a grant in and of itself and or as a component of other grants. And here's some of the examples that we do. In fact, we even have R01s that are used to support core facilities. And shared instrumentation awards that are part of core facilities are another way that we support cores, especially through the instrumentation that we provide within the core. So again, this adds to the complexity because we support cores in many different places. When we support a grant that's specific for a core, it's much easier to track. So if we have a center core grant program, we easily can track those cores. But if they're charged or part of another grant program, oftentimes it's much more difficult to be able to track where cores are and how we can index all the cores we have, and how you at your institutions even can be aware of all the cores that might be supported. So that is a source of complexity in trying to track cores. And if we're going to think about becoming more efficient in how we use cores, then we certainly need, first and foremost, to know what core and core facilities and core resources exist. So we fund them in many different ways. There are institutes and centers within NIH, again, as I just mentioned, fund through many certain activity codes and programs. They may have some restriction on how much of a particular program can go to a core facility, so there might be a cap on the funds that are available to cores. And then you all, as we just said, had distributed oversight versus centralized oversight. And the core themselves may service different groups at different institutions. So we have institution-wide cores that may be servicing many different departments and, in fact, go across departments. We have center cores that are part of our center programs. It may be within a division or a department. Then here's a place where we do find that it's oftentimes more difficult to track cores when there's an investigator who has a core, often R01, or a group of specialized cores that are very particular to a particular project. But they also can be dedicated foundation or agency cores, so there can be a core that's NIH core or a foundation that you might use. And then there's also commercially funded cores. Again, this adds to the complexity of cores because of all the different ways that they are funded and also the different goals of the cores and who they're servicing. So where we can find commonality among these different ways that things cores are supported, and also who they service and what they service and what resources they have, that will go a long way for helping us find efficiencies. So one of the things that we're working on is ways that we can improve data on components and cores. So how can we track the cores that we have and use those data to tell us something about the cores, how they're used, what successful accomplishments align with the cores through the research we support, et cetera. So oftentimes you will see at NIH that when we put out a funding opportunity announcement, there could be project-specific core reporting requirements. So you have to be aware of, if we're going to support a core this way, that there could be different reporting requirements depending on the funding opportunity announcement. This, again, adds to complexity because we don't have all the same reporting requirements for each and every core. We are able now to capture some structured data about cores on the RPPR, which is the annual progress report. And we are transitioning all of our grants to come in on the electronic submission, including all of our complex mechanisms, including our core facilities that will have an electronic submission in the future. We hope that will allow us to get more standardized data, and we can use those data, in fact, to find efficiencies and to track our cores more easily. So just to give you an example, and Jim is going to point out that it says our parent awards are $2 billion in cost. That does not mean that we're spending $2 billion on cores specifically. But here it is, all the different mechanisms that we support across many of our different institutes that do support cores. And I believe, Jim, you're going to say that there's about $900 million that we know of core support directly, but we have over $2 billion of cost for all of those different kinds of mechanisms that support cores. And you can see our big players, NCI, which is cancer, that's the CA down there at the bottom, and then many of our others. If you're not familiar with our two-letter acronyms, and I'm going to have a test for you after we're done here, GM is our General Medical Sciences, HGAI, which is our Allergy, Infectious Diseases, Mental Health, Digestive Diseases, and Kidney. And it goes on and on. So you can see that we do support cores at most of our institutes that have these mechanisms, but to the degree that we support cores varies among the institutions. So we're happy today that we're going to have Cancer NCI with us today to talk to you about how they're supporting their cores and some of the issues for cores because of their large investment in these areas. So one of the myths that we hear very often is that whether or not there's flexibility in sharing core resources. And we'll talk a little bit more about this later on today, but we do provide quite a bit of flexibility about sharing resources, not only among our cores, but among projects that could potentially use the cores funded across our agency, and in fact, for projects that are supported across other agencies. We did, at the time when we had our meeting in 2009 on efficient managing and utilization of core facilities, we put out a number of FAQs on cores. And there was a lot of examples in there, and we're not going to go over all of them today, but how does NIH funds use for cores? Can one core support another? And where do funds to pay core facility rates come from? There are some issues with indirect cost rates. So I would encourage everybody to take a look at those. Many of those questions are still very useful in our discussions today, and they answer a lot of the questions that individuals may have. Now, if you think about what policies apply to cores, basically the same management policies that we have for all of our research grants will also apply to cores. But there's some focus. There's certain things within the cores that, of course, are distinct. And one of the issues that all of us face is the recharge activities and what user fees and other facilities can we use. So there's a lot of issues regarding program income and how we make charging. There also is issues with indirect costs because large and complex cores often require sophisticated facilities which impact the indirect cost rate. So there's issues there when you take on cores. We have to deal with what it's going to mean to the university for its indirect costs and how indirect costs are charged. So we just put out, our OMB just put out a new uniform guidance. And what uniform guidance means, and I call it UG, uniform guidance. Some have heard of it as the Omnibus Circular. We took a number of the cost principles and grant policies regulations that are through OMB and put them all together into one new circular called the Uniform Guidance. And there are a few things that are going to impact cores. Basically, the requirements are largely unchanged for the management and the costing of cores, but there are some things with procurement and administrative clerical costs and how you can do a fixed amount of awards that are going to impact our cores and our management of cores. So one of the things that I want to point out is that we now are allowed through the uniform guidance that some central services and personnel that are integral to the project can be direct costed to the activity. And they have to be involved specifically to the project, and this will have a lot of impact on cores who have dedicated personnel within their budget. Of course, you have to have those individuals identified ahead of time in the budget, and they have to have prior written approval. And these costs then are not recovered as an indirect cost. So if you're going to direct charge the services, then those are not part of the indirect cost, and they should be separate and distinct those activities. But this gives cores and other research grants more flexibility in order to direct charge some of the individuals that are integral to the project, and that without impacting the indirect cost charge. And so this, for our smaller cores, this could be very beneficial because they could be charging these individuals where they have a distinct need for administrative and other types of support where they couldn't before, and now it can be charged as direct cost. Fixed amount awards are very important for cores because when the federal agency provides a specific level of support without regard to the actual cost incurred under the report, it makes it much more easy for all the administrative burdens and record keeping. So fixed amount awards are authorized under the new uniform guidance. So in the way that we can give fixed amount awards as will benefit, I think, the cores going forward. So we need to think about some of the policies that we have regarding cores, and one of the things I really want to talk about today with all of you is the idea of how we, to enhance our effectiveness, what kind of metrics do we need to measure in order to improve this effectiveness? And really the other issue is how do we best share our resources in these tight budget times, as Jim had mentioned. The best thing we can do is efficient, and when we're supporting these cores and or you're supporting these cores, how can we best see that they're used to their full capacity, that they're shared among our projects, and that we find as much efficiencies and effectiveness as we can. So what kind of things do we have to measure? How can we identify all the cores that we are supporting and or you're supporting to be aware of all those cores? How can we communicate about the cores so that individuals can find cores that they could use and core facilities that they could use in their projects, et cetera, et cetera. And then basically we want to work with you in partnership to see how we can facilitate these goals. And that's it. And Jim, I think we'll just go on to you, and then we're going to have a panel at the end, correct?
We are, but we have, I think depending on the time after each, we could take some very specific questions for the speaker directly.
Okay. I have a surrogate in the audience, which is Joe Ellis. And Joe has been intimately involved with cores for a long time, so if I might have difficulty hearing the question, or Joe, you might be able to answer it more readily than I. So we'll take a couple questions.
Okay, so these would be more about very specific current things, not what we want to see in 5 years yet. We'll get to that.
So my question,
it's a little,
okay.
Yeah,
my name is Phil Hochberger. I'm from Northwestern, and I'm co-chair on
I hear you.
Can you hear us, Sally?
I can hear you, yes.
Okay. And I'm the co-chair of the CAN-CC, the Administrative Committee for the ABRF. And Joe Ellis was very instrumental in helping us get the FAQ written. So my question for Joe and Sally is, this fixed amount, I don't think that was in the FAQ. So could you tell us a little bit more about that?
Yeah, Joe?
He's on the way up, Sally.
This is an area that wasn't formally recognized in the old cost principles. It did happen from time to time on individual grants, but it was done on an ad hoc basis. And the idea with this is when you can make a determination on what's a reasonable cost for an activity, say a function in a core, on a reliable basis, you can negotiate that with the federal agency, or if you're a sub-award with the grantee, the awardee, and then you can agree on a specific rate of reimbursement for that that represents reasonable cost. At that point, if it's declared a fixed amount award, then there's no cost accounting required for that. You can move away from that. You can manage cost as you would at your institution for other activities, maybe not as you would do if you're doing with an NIH research grant where you're dealing with cost reimbursement and subject to audit. The goal with this is to move away from accountability that's based on accounting processes and procedures and move forward with methods that would look more on the quality of the service and the efficiency of the service. So I think it works well with the concept of what we're talking about today. Obviously, this can't be done for something where you start an activity and you don't know the end point, what it would require to get to an end point. But if you're doing with a fairly routine level of service, this could represent an opportunity to cut down on some of your administrative burden in managing these activities, and that's the goal, I think.
I'm sorry, I just wanted to add that with cores, there's so many services that likely could be fixed amounts and fixed cost amounts that it would behoove most of you that have cores to think about what services could be a fixed price service. But like Joe said, you really have to have it very distinct, know from the beginning to the end what that's going to cost you. But it will save a lot of burden.
Okay. Other specific questions? Okay, then I'll go on. Thanks, Joe. Okay, I'm going to reinforce some of the issues that Sally brought up, and I'm also going to give you some good news. I'm going to give you some results from an experiment that was done a couple of years ago in attempting to share core facilities. But I'm going to start with some observations, again, as Sally said, that really go back to 2000 and 2010 when we had some workshops with institutional leaders about core efficiencies, and ABRF became very involved at that point. And just to make these background points is that NIH does spend a lot of the resources on core facilities. A pretty conservative number from 2010 that's been published in Science Translational Medicine in 2011 is that there's close to $1 billion that is spent on the core science part of cores. And this is probably just in a smaller number of the mechanisms. It's not in all of the potential mechanisms. And as Sally has pointed out, NIH is working towards being able to more reliably account for the cores. But going backwards, it was a little difficult to know how much was spent and how many cores there were and where they were and what they were doing. So this is a soft number, but it turns out to be a lot of resources go to the science of a core, which is not a bad thing. It's just, is it efficient? There is plenty of anecdotal evidence. I left academics 5 years ago, and I had a responsibility for cores consolidation at UNC, and I can give you my own lessons there about 3 peptide cores which it seemed a strange thing to have at a university 5 years ago. But there is plenty of evidence that there's redundancy of core services within institutions, like 10 histology cores that do overlapping activities. There's funding of similar cores within an NIH institute. And remember, there's 27 institutes at NIH. Not all of them are involved in cores. But there's plenty of evidence that they fund similar cores in the same building and have very little knowledge that they're doing that. So it's difficult to document this. And it's difficult for you folks to know about it at your institution sometimes, and it's difficult for us at NIH to do it when we're planning support. Sally brought this up too. Another thing that we hear from many is that this urban myth that there's something about NIH policies that discourage sharing. And when I talk to research deans or core directors, they say, well, it starts with peer review. You know, I can't share my core because then the folks I'm trying to fund with this P30 won't have access to the services. There's nothing explicit in NIH policy that discourages that or directs people to do that. There's also, there are cultural issues within institutions. I've written core grants, and there is some amount of influence in an institution if you're the one that brings in the core. So how do we change that so that it's positive that you brought in something that the community shares rather than it's me? I did it. My tenure, my advancement depends on me making the core instead of us. So that's a cultural issue. And then it's also very clear that many institutions have taken this issue on and are highly centralized. They're very knowledgeable about their core systems, building collections, planning ahead with instrument purchases, use of space, and they are efficient, but there's an extreme range across the country. And so part of what we'd like to do is hear from the schools who are very successful, and they'll be represented in an hour or so, to hear what were their problems, how did they overcome them, and how can we then share that with other institutions so we can all get up to a more efficient level. So I'm going to spend the rest of my time addressing the question of whether you can share and whether it leads to better science and more efficiency. And this was just a quirk. This was a result of the economic crash of 2008 and the economic stimulus package provided significant funds for NIH to support purchase of American equipment and to enhance employment, so an economic stimulus. NIH spent those funds in many ways. One of the uses was to ask the question whether core facility support could be used for the purpose of consolidating multiple cores into single, more efficient cores. So this resulted in a solicitation for applications to do this. It was a supplement system, so it was supplements added to existing core systems. And it asks that the applicants consolidate core facilities and that they be made widely available, but they also do it and operate within the scope of the parent grant. In other words, if there was a relationship with a certain group that used the core, you couldn't change that, but you had to make it more widely available to other folks. Conveniently, whether applicants knew it or not, but they also agreed to share their practices, which is something we don't, other than progress reports, we don't often ask people to come to workshops after they get funded or to write up what they did and put it on the web as best practices. But in this case, it was done. 12 of our institutes participated in managing the distribution of these funds, so it was very popular concept at NIH. And the funds could be used for personnel to plan and implement the consolidation. Remember, it's a bit of a funny experiment. You were supposed to increase staff because of the because of the downturn in the economy, and also purchase equipment, so folks could purchase up to $500,000 worth in pieces of equipment. You could also do minor alterations and renovations. It was very popular. There were 80 applications received for this. And in the end, after peer review, there were 26 administrative supplements, and they ranged from $300,000 to $1.3 million. Most of them, 18 of them, went to P30, so typical center grants, NCI center grants, other institute center grants. A few went to other mechanisms, but the P30s that everybody's familiar with, those cores, that was the most popular. And in all, there was $22 million was used to support this experiment. Just for your reference, and I won't read it, here are the institutions. It's a range of institutions, public, private, around the country. They're all among our higher funded institutions. So there they are. These slides are available if you want to take another look. And then we took advantage of this stipulation in the applications that you do more enhanced reporting. So we went back to them last year and we asked 13 specific questions. And some of these I'll read so you get a sense of what we asked and why. I'll also point out that all these results were just published as a report on this supplement program in the ABRF journal. So you can also find that that's now online. So the first question was, how many core facilities and what type were proposed to be consolidated, and then how many in the end were you able to do, and was it successful? Things about efficiency such as space, did the space change, the total space? How many staff were assigned to work before and after? Did it lead to better science, things like allowing more efficiency through cross-training? Did it increase the availability of core services and the number of users who could be served? And we asked for some quantitation on that. And we also asked for the number of projects or services provided in 11, 12, and 13 to get a sense. That was the period over which they could spend the funds to become consolidated, so we could watch the trend. Did it lead to more efficiency through centralization, like billing, purchasing, service scheduling and tracking? Were there other efficiencies that we didn't ask about? How did you publicize this? So did it lead to better science too, was another question we asked. So there's a large amount of information that we collected, and it's available on our website as the original comments. So it's you can find out what folks' personal experience is, and in the ABRF journal you can find a summary of this outcome. And I'm just going to show you a little bit of the data here. First of all, which kinds of cores or from which institutes were able to be consolidated? We found that most often people consolidated 2 cores. That's on the far left there. NCI, you'll see, is our major core supporter, major single core supporter, and you're going to hear about their system in just a few minutes. But in 4 cases, NCI was able to combine 2 of their cores. Other individual institutions like National Institute of Drug Abuse, Neurological Disease, and Stroke all were able to combine 2. But it was also possible that they found to combine cores that were funded by different NIH institutes, which is, we find positive because, you know, that could be a long-term goal. And it also allowed them to stay with whatever requirements they had for servicing the individuals that were funded by that institute. So you can clearly combine cores across NIH institutes without a problem. There are also examples of combining 3, 4, and 5 cores. And the 5 cores, one of them was environmental health and health safety, EPA, and Department of Energy. So we could even go across federal agencies successfully and still service the individual participants who went into the consolidation. So as it turned out, there really were not insurmountable problems in consolidating the cores across these different groups. We also asked, did it increase the number of users that could be serviced and the number of services that were provided? And here it was uniformly positive that all 26 awardees reported that they had increased the number of users over what they were doing before, the number of services, or both. So, for example, the top bar reports that 20 or almost all, increased the number of users, and some up to 3-fold. They also increased the number of services that were being provided by the combined cores, about half, a little more than half, and up to twice as many. The others were just not able to report as much data, hadn't kept it as efficiently, but they all provided a positive result from this. So where did some of this efficiency come from? It came, some of it from administrative consolidation. For example, the green bars represent the numbers of awards where there had been centralization of the billing, purchasing, scheduling, and tracking. And you can see that was very positive, and they reported to us that was a source of increased speed in the work and also efficiency, lower cost. And this was really, this was an astounding outcome. We also asked, what was your annual income or program income that was generated by the cores, and before and after doing the processes together or consolidating? And where the data was available, it was all strikingly positive. For example, these are de-identified schools, but the first one, before consolidation, their program income had been about 2.5 million. This is a large core. But afterwards, about 4.4 million. If you look at the 4th one in school 21, was really not addressing collections at all. But then afterwards, it was collecting about $1 million. And this was uniform. I think there was just more attention to the process. Now, the program income, and I asked Mike Chang, who works with me, can address what you can use program income for, but you can use this for equipment, hiring new personnel. So this is income to make the core work better for you. So I think the lesson here was pretty positive. And I don't think it was unique to this. I think the unusual part was because it was a recovery program, it poured money into it. And I think that might be unusual for NIH to be able to do that at this scale in the future. So one question would be, can we do this at lower money? I mean, where is the real priority? What held you back? And if you put 50,000, 100,000 on that problem, we could have gotten the same result, for example. So that's something I'd like you to think about. How could we duplicate this but at lower cost? So what did we learn from this program? First of all, it's clear that cores can be successfully consolidated within an institution and also across NIH institutes and centers and still serve the original folks who were funded for their part of the cores. Where did this efficiency come from? And I'll summarize, you can find this in the article or on our website. People's comments were it came from management efficiency, billing, purchasing, scheduling. Some folks said that they were able to centralize the data processing, that licenses and softwares, if they were buying them together or one, that led to more competitive prices. They could bring down the prices from the vendors for materials as well. It also led to more centralized oversight of the facilities, so that at the dean's level, they could plan space use better, understand who needs to have out-year support for licenses and instrument upkeep. It allowed cross-training. We often heard that, just anecdotes that people would come to a core thinking they wanted to do X, and after consultation we're told, no, you really want to do Y, and we'll help you do that and do it better. So many reports that this just led to better science. And frankly, you know, that's what we're looking for too here, is better science, not just lower cost. So as Sally did, I want to throw out for discussion throughout the afternoon some of these questions. What's holding us back? What are the obstacles to making this whole thing more efficient? If you buy the idea that centralized management is efficient, and then the question is, what types of cores should be centrally managed and which shouldn't you? Because there really are things that don't make sense to share, and there are others that do, and what are those? And are they things like policies? We'd like to hear, do you think NIH is doing something that's preventing you from being more efficient, and how can we change that? Cultural issues are bigger. I mean, we just have our whole funding system is based on the PI who competes and gets the best score. And we need to accentuate the team science part of this and working together, and many people contribute to the science in different capacities. How do you change that and still advance people's careers at your institutions? And then Sally brought up, we're doing a better job, I think, with the lack of awareness issue. If our staff wanted to check about funding a core in a new P30, they would have had a very difficult time knowing whether there was a similar facility across the hall. I just think that's still the challenge. But what can we do to enhance that, to make that better, and what can you do to make all of us aware of what's available? And then what are some incentives to get there? Yeah, we're not going to put $22 million into another program next year, but what other things can we do to incentivize efficiency? And then again, I want to admit, cores are a very heterogeneous concept. They're not the same thing. So some discussion about what can be shared and so where's the low-hanging fruit here? Where can we really get something, get it more easily, and do it with the least funds? And then what are things that aren't even worth thinking about sharing? And also scale. A question came up, you know, we have 3 synchrotron centers in the country, and that seems to work. Are there other things that we could centralize on a regional basis or a citywide or statewide basis? So if you have thoughts about that, we'd appreciate that too. So with that, I think my intention was kind of to set the background of what we were interested in. And if you don't have really specific questions for me, I think we'll go on to our next speaker.
I just want to, Jim, could I make a mention of something?
Sally, yes.
Yeah, I just wanted to mention one thing that we all want to think about is ways that and hear from you how you track cores across your institution, because I think in any consolidation effort, you know, the foundation for all of that and the first principle is to know what cores exist. So we'd love to hear from you how you're managing to index or keep track of what cores exist on your campuses so we could share those best practices.
I'll expand on this since we have about 5 minutes. The databases at NIH had not been set up to quickly report on, in granularity, core systems around the country. That's not, they were intended more as transactional, financial databases. So we, last year, had a little exercise of trying to determine what was really spent. And we ended up just picking a handful of schools, boring into our records and doing it manually. That wasn't so successful. So we ended up going to the website, spending weekends Googling you, and trying to figure out what in the world number of cores there were at institutions and what they did. And that's where we reconfirmed the idea that there's a lot of redundancy here, folks. But then it's also very difficult to find it. So how do you even know about it? And it's just one more comment is I've talked to a lot of research deans about this, and I have to report one I spoke with in the top 15 NIH funded said to me, but Jim, if I wanted to do that, I'd have to know what cores we have. And I thought, is that where we are? Okay, please.
Matt DeVries, Case Western Reserve University. We have 46 cores. But my question about the consolidations, what was the nature of the consolidations? Is this the confocal from 2 different centers being put together in one, or is this putting confocals with flow cytometry into one core?
They tended to be similar technologies. For example, a range of genomic technologies were put together. Imaging was not so common, but they tended to be similar technologies, not so that they could share the same types of tracking and the personnel could help across platforms.
Chris Colangelo, and I was just curious, on some of those graphs you showed, it actually looked like some of the awards you gave actually gave you almost a return on your investment, and some look like you, especially in the income they brought in. Is there any practices you can learn about them compared to other ones that seem to get very little in increased income or increased efficiency?
We can try that. The reporting was probably not adequate to tell us those lessons of what we would look for. The other question is this really more efficient? Where did that program income come from? It came from our R01, people being able to put more money in the core. So is that really an efficiency? I'm not sure this is going to save all of us $2 billion, but I'm sure it's going to make better science.
Hi, George Gross from Cornell University. So I was just going to suggest in terms of the challenge of developing a national database of cores, that it would be useful to have some type of funding opportunity to actually start that. It takes an initial investment to actually build that up. The ABRF is one good mechanism. There might be other good stakeholders and players in the field that could contribute to that as well. But the real barrier is the initial investment to actually move that forward. And related to that is not just a database, but some type of annual comprehensive survey of cores to make sure that you have a continuously updated snapshot of what the community actually consists of. And again, that's a funding obstacle.
So can we come back to that later? Because my own impression is I don't care about all cores, okay? There's some priorities here. Some are not worth sharing. Some are high priorities. So there has to be some strategic thinking about what a resource like that looks like. So I'm going to go on now. We're going to have Todd Wilson, who is from the National Center for Advancing Translational Science. He's going to present on the CTSAs. And well, he'll explain what the CTSAs are. This is the... I'll try. Okay.
I will try to do that, which I hope you'll have a better appreciation when we're done. I'm a medical officer with the National Center for Advancing Translational Sciences, which houses the CTSA program. On behalf of our center director, Dr. Christopher Austin, I'd like to say thank you, and our Division of Clinical Innovation Director, Petra Kaufman, also thank you for inviting us to participate in this workshop. A very important workshop. As you're aware, the CTSA, or maybe not, the CTSA program and formerly GCRC program has invested in the past in resources and services, including cores. So historically, there is there's a story there. But what I really want to share with you today is also what the present thoughts are from the CTSA program, and more importantly, the future directions that we're going in. And you may think at times when we're going through this presentation, I'm getting a little off topic, but I'll try to bring it back around, and I hope you'll understand and share the excitement that we have as far as we're moving forward and how cores may participate as we move forward. So that being said, for those that aren't familiar with the CTSA program, it's a national consortium of medical hubs that's been charged to work together to improve the way clinical and translational research is conducted nationwide. We do provide training for clinical translational researchers. I'm not going to emphasize that today, but that is a central mission of ours. The program itself evolved, as I mentioned, from the GCRC and clinical training programs as part of the new NIH roadmap for medical research. Basically, we were doing a poor job of getting therapeutics and drugs to patients that needed them, and there was basically a mandate that said we should be doing this better. And from that, the CTSA program was charged and established in 2006 to address re-engineering the way translational research is conducted. In 2011, the National Center for Advancing Translational Sciences was formed. The CTSA program is a natural fit for that, and it does now fall under that center. Just to highlight what our mission is to catalyze a generation of innovative methods and technologies that will enhance the development and testing and implementation of diagnostics and therapeutics across a wide range of human diseases and conditions. Now, I think the last couple of sentences there, last word there, a couple words there, a wide range of human diseases and conditions is very critical to our mission. We are not disease specific. In some ways, we've been termed disease agnostic, meaning that we are looking for commonalities. We are looking for improvements in the way methods and processes, cores, other resources and services are provided, and finding common roadblocks that can be overcome. It may be through a disease-specific model, but we're trying to find the commonalities to then allow larger adoption, if you will. There are 3 Ds that Dr. Austin likes to reinforce to the program staff. That is the first one being discovery, the second one being development, and the third is dissemination. And I think that the third D, the dissemination, really applies to us today, which is what are the best practices out there, and what are the standard ways that we could all adopt that might improve efficiency. And I think that's critical to our mission. I want to share that with you so you understand that's where we're all on the same page in that regard. So the sites are 62 total sites, and they range and vary from large urban institutions all the way to rural, smaller institutions. So we have great variety, which I'll point out is a challenge at times to try to standardize, and I think you could appreciate that. So I think that is one challenge that we have. I'll tell you, going back to that slide, is that if you ask the program officers about the CTSAs and try to ask, well, if you've seen one CTSA, well, there's a general feeling that if you've seen one CTSA, you've seen one CTSA. They're all different. They're all very, and they all have their strengths and have weaknesses that are unique to them. So we were given a mission to change the enterprise. Well, the enterprise is big. It's believed that our budget is around $472 million, which seems significant, which is significant, and represents about 2% of the NIH budget. However, when you look at the overall investment into the R&D side of things, it represents about 0.5%. So really what we are doing, and the approach we're taking, is acting more as a catalyst. We may need to make big, impactful changes that have common solution and generalizable solutions. So I think, again, that speaks to the needs today of this meeting. We offer a lot of different resources, services, as well as other entities, other components to our program. It goes all the way from preclinical all the way to dissemination, as I mentioned, which would include comparative effectiveness research and community engagement. I'm highlighting here just some of the examples of cores that we've supported in the past. Translation genomics, and this is not meant to be inclusive, this is just highlighting. High throughput screening, and probably the one that we're most known for are our clinical research units. And that's been the foundation from day one with the GCRCs, and it is where much of our history has been focused. So I'm going to pause here for a second because I want to highlight and echo actually some of the comments that Jim and Sally have kind of pointed out already. And I kind of led into it by saying if you've seen one CTSA, you've seen them all. There are the way that we charged these CTSAs to function is we asked them to tap into their local strengths. That is, ask the investigators what they need, create resources and services tailored to those investigators, and more importantly, then apply metrics to those resources and services and report those back to us. A third part of that would be also the budgeting side of it. Many of our CTSAs have engaged their business schools to help participate in coming up with business models for these, let's be honest, these are businesses in some ways, in many ways, and to come up with business models to assist them as they develop their cores and or resources and services. The third and the fourth part of that was that we also asked them to leverage the money that we gave them from the CTSA program and to try to bring in other monies such as private foundation, other NIH ICs, et cetera. So we've asked them to leverage and really maximize the impact of these resources and services that we've provided. I highlight all that because all of those have posed a challenge to us, which is at the end of the day, we need to be able to say, what has the CTSA program done in aggregate? And when you have many of those local challenges, those local reports, trying to overlay standards on all of those sites with standardized reporting mechanism is a challenge, and I would love to hear feedback from you as we move forward on how that might be a solution for that. It does present a transparency problem for us, both locally and nationally, to be able to talk about the CTSA program, not only as it pertains to cores, but across the whole program. However, the consortium has made efforts. They recognize this, and the sites do know this. So I'm going to share with you a little bit of data that came back. This is coming from our clinical research units, a report that came out of the CTSA Resource Sharing and Cost Recovery Subcommittee. I'm not going to go through all the data. I'll just give you the highlight on it. There are a number of they did a survey looking at the number of CRUs that are being utilized from roughly about an N of 20 of CTSAs. And what I'm really trying to emphasize here is that the mechanism by which these have been funded in the past, which was traditionally the GCRC of full subsidy, is no longer being utilized. And many of these CRUs have moved to a chargeback mechanism, not only for industry studies, but also for foundation studies and federal studies. And I think Jim already showed some of that up front on some of his study that he showed. So the consortium is aware of that. They were also aware of the transparency issues, and there have been some efforts to become more transparent of not only the services that are offered and resources, but also the budgets. This is the South Carolina CTSA that has an open multi-institutional integrated web-based research management system. They call it SPARC, Services, Pricing, and Applications for Research Center. You may be familiar with this, and I'm sure that many of the institutions that you're going to hear from may have a similar approach. That is where they offer a menu of a catalog of different options for services and cores, and you're able to price it out and come up with budgets for your project, which the PIs could then plan for their studies. As of now, there are about 4 or 5 other CTSAs that adopt this, and it's open. You could go to the site right now and try to plan your own study if you wanted. So that's just one example of how we've tried to address the transparency issue. You're probably familiar with this, Eagle Eye. It came out of an earlier CTSA initiative, among others that have funded it, to try to address what's out there. Can we get an assessment of what's out there? And this is one attempt at trying to do that. Another example of the way we've tried to do this is through our coordinating center at Vanderbilt. They developed a catalog of assets, if you will. A survey went out to all the different 62 sites to ask what what kind of services and cores and facilities that they offer. And what that would allow you to do is, as you can see on the side, I've picked out high throughput screening, but this allows you to then sort of get an assessment, and as you click through each one of these assets, you'll highlight on the map where they're located and the contacts that might be available. Just as examples of the consortium responding to the understood problem that we have with transparency and understanding how we could standardize things a little bit better. So if that wasn't emphasis enough for the CTSA program, the Institute of Medicine came down with further recommendations for us in 2013. It was, and I won't go through the whole, it was based on Congress came in and it was asked for this review. And the formal recommendations were a total of 7 that have been distilled down to 7. I'm going to highlight the first 4 for you because it shows you where we're going. This is the vision part of the program. We were charged with strengthening the leadership of the CTSA program by NCATS, reconfigure and streamline the consortium, and build on the strengths of the individual CTSAs across the spectrum of the clinical and translational research. And I think this 4th bullet is actually very it hits home for, I think, all of us, is formalize and standardize the evaluation process for the individual CTSAs. So I'm going to talk to that one for a minute. We have now built metrics into our new CTSA FOAs to start tracking these, to put together what we should be tracking. This is a work in progress. The NCATS has developed a CTSA working group to develop common metrics. This includes NCATS staff, PIs, and we also are involved with an external consultant. And we hope to incorporate and leverage prior work on metrics, but also I think the last bullet there underneath that, underneath the working group is to minimize administrative and data burden on CTSAs. I think that's very important. The last thing we want to do is to add more bean counting, if you will, to a system that's already maybe overburdened with such, and we need to be cautious of that. And we also need to be cautious of how that data is going to be used during review. So I think we could talk about that maybe in a session. And ultimately, we also have set up new domain task forces, methods, processes, informatics. You'll see them there. These are representatives from 62 of our sites, really to get feedback on the implementation process. We hope to engage them once this goes live and to get their feedback. It's our communication link to them. So I mentioned the new RFA that we have. The components are as we've had in the past, a U award, a K award, and a T award. You'll see overarching topics and required modules. You will see in there that there are elements of resources and services that are still provided and we will be tracking. There are optional modules for each local CTSA to highlight their strengths and be able to work in domains that they may not have been able to work in, that we're not limiting them just to certain domains to work in. The one I've highlighted there in red, or I've bolded in red, is for network support. This is an answer to the IOM report that said we need to have more network activities, and we need to stop doing, not stop, but taking what we've learned locally and create a full network in this program. So leadership has chosen to move in this direction from a multi-site clinical trial perspective. And this isn't traditionally what we think about in cores, but based on Dr. Rocky's lead-in, I would arguably say this might fit into there somewhere. The traditional model is, and I'm just sharing with this, bear with me on this, on the clinical trials. The traditional model is that trials are rebuilt from the ground up. We have decentralized IRBs, we have splintered and complicated compensation packages, and we often overestimate the amount of patients that are actually out there for trials. The new model would be that we stand up a prefabricated and funded clinical trial infrastructure. That is where we have these sites that are willing to participate, we have master trial agreements and central IRBs, we have using electronic health records, be able to improve our recruitment times, and also a way to engage eligible and willing participants. And this is the focus that we're heading in at this point. And just to reemphasize the need for this, many of you, I don't need to tell you about the Boston Marathon bombing. I think everyone understands what happened here. But what you need to know is that Harvard CTSA had set up an IRB reliance agreement. And those who aren't familiar with IRBs, what it means is that if you want to set up a protocol quickly, you need to have buy-in from all the sites, and that process could take a long time to make sure you're not, to do all that. By setting up an IRB reliance network, those agreements were already in place. So when this occurred, doctors at the Mass Eye and Ear in Boston wanted to learn about blast-related ear injuries, and they wanted to study the bombing victims. So this allowed rapid IRB approval, and we got them on quicker. If we can do this in a time of emergency, such as now, we should be able to do this for the patients who are waiting around to get on clinical trials that are being delayed because of IRBs. I'll just say that there. That brings home the value of standardization. So the vision, right now we have pilot CTSA network initiatives underway. We have the central IRB, which I mentioned, and that's going to go into a pilot project plan phase. We have a contracting that we're set up with industries as well as NIH funded studies. And we're also coordinating that with the CoreNet. And finally, electronic health records, which I mentioned. We're trying to integrate all the electronic health records within our consortium. So this is our heavy informatics load right here. This is a heavy lift for us to be able to do that. And our goal is to have all 62 sites have electronic health records that we can access for patient recruitment purposes. The ultimate goal is, and coming back to, if you will, cores, is to set up trial centers. One, we would set up a trial innovation center, which would provide these clinical trial support using the infrastructure I've already described, and also coming up with innovative approaches to increase trial efficacy and effectiveness. And in addition, we'd also like to set up recruitment centers to improve the recruitment to these trials. This is a major focus of our efforts. We hope to have that electronic health record system up and running, and then develop recruitment plans in addition. Now this would work as such where the CTSA hubs would all feed into these RICs and TICs that would offer different resources and services, if you will, to mainly our IC study sponsors at this point that want to do multi-site studies. It could be to other pharma and other agencies as well. But by having these up and running and as a standing core, and I use that word I think loosely, we won't need to rebuild trial components each time. Now, why did I share this with you? I know it's a great story. It probably is far outside the why we're here today to talk about cores. I use this as an example. This is where we're focused now. It's not the end all. It's not what and I don't want you to take away that CTSA program's only focused on clinical trials, because that is absolutely inaccurate. And I want to say it very clearly that that's not our sole emphasis at this point. A lot of the funding is still going back to the local sites. They're still going to develop their resources and services, and they're still going to work as an experiments and incubators of ideas. And we want to tap into those ideas, whether they're in cores, whether they're in resources, whether they're in community engagement. So we've set up also a new initiative to look at collaboration innovation awards, where basically we're going to take, part of this award will be that 3 CTSA sites have to work together, address a common roadblock, and show that you can demonstrate that it works, number one, and also that it can be defined and measured, and taking those projects further. And if they work and if they look good, we will adopt them if they move things further if the science is there that needs to be moved in that direction. So I just share these with you. I know more as vision than cores, but I hope you appreciate we've gone through a lot of evolution in this program, and we continue to evolve, and we need your feedback to take us in the right directions as well. So the take-home messages are the current pace of drug development cannot meet the needs and opportunities, cannot meet the current needs and opportunities. We need new infrastructure. We're using old infrastructure. And our program has begun to transform itself to meet these opportunities, improving methods and streamlined processes, as well as training the next generation of researchers, and in collaboration with our NIH partners, which is critical for all this to work. And I'm glad we're having this discussion today to try to work through some of the common problems. Thank you.
Thanks.
Did you want me to take?
I think we'll go on.
Yeah, that's fine.
And bring you back up
That's
for
fine.
the panel. So we'll go on to Michael Marino, who is going to address the NCI-supported Cancer Center core facilities. And this is our largest single organized group that supports cores.
Thank you. I greatly appreciate this opportunity of the organizers of ABRF and NIH to share with you about the NCI, which is the National Cancer Institute's Center Support Grants. The grants themselves, part of it is the core system. We often refer to the cores as shared resources, so I'll be using those terms interchangeably during this presentation. What I plan to do today is just go through briefly the mission of the Cancer Center program, the P30 Cancer Center Support Grant, which is a CCSG. It's a rather complex grant if any of you have been involved with putting one together. The history, purpose, types of centers, and then I'll move into the NCI's Cancer Center view of the core facility shared resources. Some of that has to do with the peer review process, and also then move into how we account for the cores at the cancer centers and some of the future direction. The mission of the NCI Cancer Centers program is to foster excellence in research across a broad spectrum of science and medical concerns. And this, it doesn't stop there. We want to actually take it one step further, and this is where it becomes translational, and that's to extend the benefits to the research of patients, their families, and the general public. So this is something that's written into our mission, and it started in 1971 with President Nixon actually signing the National Cancer Act. Here's where they declared war on cancer. They knew that they couldn't do it alone. There were a small number, but a number of established cancer centers at that point. So what the idea was, we're going to have the National Cancer Act, which is going to enhancement and enlarge the existing cancer centers. It's going to foster new establishment of new centers, establish the P30 grant, which is the funding mechanism for the cancer centers, and then from that point, develop programmatic guidelines. They've gone from guidelines until 2013 when we actually had an FOA, which is a funding opportunity announcement. I'll talk more about that later. And then the establishment of the Cancer Center branch, which is now the Office of Cancer Centers, where I'm employed as a program director. Just so you know a little bit about the Cancer Centers, the Office of Cancer Centers, there are 5 program directors. We recently had our director, Linda Weiss, retired, so they're in the process of looking for a new director at this point. All right, the P30 grant mechanism, it's rather complex, but it was designed to provide organization, focus, and structure. It is an infrastructure grant. We technically don't fund research directly. I mean, there are research programs within the P30 mechanism, but we are looking more at the infrastructure. And the reason why this was done, it was to stimulate the organization and the coordination of competitive cancer research. In other words, the best results are going to come from the competitive base and look at them through transdisciplinary research programs. Key to today's workshop, we also provide access to centralized technology services and scientific consultation, and that's key because you can have the greatest science available technology, but you also need the consultation to interpret the data and things like that. What this will result in is enhancing the research productivity, providing a foci for scientific interaction, and also ensure stability, reliability, consistency, and quality control. So that is our purpose. Just a little bit of background. The designation of the NCI designated cancer centers. There are 41 comprehensive cancer centers. These are ones that have taken it one step further. They've shown a real depth and breadth of both the basic clinical and population science research. They have strong transdisciplinary research, bridging those areas. So in other words, the groups don't operate in a cancer center as a silo. They need to work together, know what's going on with the other groups and how they can actually use the information to put the best foot forward. And training and education. There are 27 cancer centers. Now, these combine both clinical cancer centers and basic, and the primary focus is on basic, clinical, or population science. And a lot of these, with the exception of the basic centers, have the capability of becoming a comprehensive cancer center. The comprehensive cancer centers have a different set of review criteria, so they would have to petition that they meet the criteria, and then every 5 years, at the time of their competing reevaluation, they would, apply for comprehensiveness. The organizational structure, it's freestanding, which means it has no affiliation to any institutions. The matrix is generally associated with an academic institution, and then the consortia has a completely different set of criteria. It's usually partnerships which are well defined in the P30 grant mechanism. So it's something where you would partner with someone, not just because we're talking about cancer research, it would be a clinical arm, but you'd be looking at someone who actually brings a research portfolio to your establishment also. All the cancer centers have this. There's 6 essential characteristics. They are, the first one is, of course, cancer focus. You need to demonstrate this, and it's usually found through the publications and outreach committees. Has to be justified at the center itself. Strong institutional commitment. This is key to the actual course, because you can rely on the institution at times to help subsidize the cost of the core, the cost of the personnel, and also to make space allocations, things like that. The director, this has to be a strong person. Most of these are MDs. Quite a few are MD, PhD, entrepreneurs. They are business scientists. And then strong transdisciplinary collaborations within and between the research programs. Again, this is emphasized in the program because we don't want to see isolated research. We want to see things that are actually being taken not only from the bench to the bedside, but from the bench to multiple bedsides. So, and then look at the facilities. That's just the physical space. I mean, they need to have an area in which to operate. And the organizational capabilities, this goes without saying. It's something of this size, takes an enormous amount to organize and coordinate. One thing with the 68 cancer centers across the United States, they all have in common is this. This is their structure. There's a cancer center director. He's in charge. Now, generally, he reports to someone, or she reports to someone above, and that's generally depending on the type of center it is. If it's a matrix center, it may be the provost or a dean at the university. If it's a standing cancer center, it may be to a committee or a executive council, and consortiums have consortium representatives. There's a deputy director, and then there's the associate directors. There's basic science, there's clinical science, administration, population science, and then again, there is an administrative or a person that's in charge of the shared resources. This person takes a charge and makes recommendations to the actual cancer center director when there's a need or a possibility for a new shared resource. And under that person, there are the directors of the individual cores themselves. So this structure is common to all of the cancer centers with just a few finer points. All right, the general policies regarding the CCSG support of shared resources. One, the type of resources, it doesn't matter. Whatever you think you can justify, and of course you need to show a need, but under the guidelines and now under the FOA, the center has complete flexibility in what they want to propose. The resource may need to be a center or an institutionally managed. This is something that we do not dictate that it be one or the other. The users, the way we look at the centers are, there's a priority given to the Cancer Center members. That's of course and usually the members are the ones with the peer-reviewed research, which means that they have the actual, funding of the cancer research, so that we look at those objectives. And other research is at the discretion of the Cancer Center director. The director has a lot of flexibility in this particular situation, but again, I'll go into some of the other details of budgeting. And usage is primarily focused on shared resources serving multiple members. You wouldn't have a core facility for one member. All right, the budget policies, the CCSG, they support fixed costs associated with the centers, and the key personnel. Minimal supplies can also be supplied. The budget, it varies according to the number of usage of the members themselves and the resources, and other support, including chargebacks. So each cancer center has the flexibility to actually dictate how they set the system up, how they charge, and how they go forward with that. For institutionally managed resources, it should be proportional to the number of cancer center members that are using the facility. These were not intended for highly specialized projects. Again, it's not something for one or two investigators. And I need to say this, it's not to cover any shortfalls in other funding. No one would do that, right? No. All right. And services normally provided by the institution. So we try not to mimic anything that already exists within the institution itself. It is peer-reviewed. The CCSG comes up for renewal every 5 years. During that period of time, there's a review committee that's organized. It actually does a site visit after receiving the written application. And at that point, these are the things that are looked for: the quality of the science that's supported. So this is actually in the write-up of the CCSG. The research programs will reference what cores they used and how often they used, and the results, if there were any, for example, co-publications and things like that. This is a really important fact because, I've done this for a while, and you can actually have really terrible research programs and outstanding cores, but you can't have the opposite. So you can't have, outstanding research with poor cores. There's provision for service of multiple users, of course. They look at the quality and cost effectiveness of the service, the qualifications of the staff. And when you get into some of the actual clinical applications, it becomes really complex, and the staff is scrutinized significantly as to do they have the qualifications to perform the work. And the extent of compliance with national and other standards. If an institutional shared resource is used, again, we look at the accessibility to the members, the benefit to the members themselves. I mean, is this something that they, are reaping the benefits of rather than not using that particular one? And another key point is when I showed you the schematic of the cancer center, the administrator that's in charge of the shared resources also participates in the center and facility planning and oversight. This has to do with a couple of things: space allocations. It has to do with any new core that's being suggested. They have a voice in it even when it's at the institutional level. The CCSG funding was like this. In 2010, a total award in millions was $271 million. And it has stayed pretty consistent through 2011 and 12. 2013, it did drop a little bit to about $245 million. That was due to cuts in the budget. The number of centers started at 66, and in 2012 went up, and 2013 to 68. There are a number of emerging centers these are the centers that are trying to obtain the NCI designation. That it is a long process. I mean, just filling out the CCSG takes almost a year for an established center. So there are a number of centers that are are trying to obtain the designation as we speak. The point that I'm making here with the shared resources is this. Out of the, for example, the 271 million, 55% of that was spent on the shared resources or the cores. And you see that number has been pretty consistent across the board, taking into account the dip in 2013. Now, the shared resources themselves, they obtained money at around 98 million down to about 78 million. And I know if there's anyone who's sharp with mathematics, you look back a page and you say, that's not 50%. There's not to give you a lesson on the NIH money, but there's total cost, there's direct cost, and there's indirect cost. These are the direct costs. And this has to do with the way we keep accounting of the cores themselves. Because it was mentioned in one of the previous talks, there can be a significantly higher indirect cost for a core. And so we thought it was better just to keep the direct costs accounted. Total number of cores supported in 2013 was 688. The average core per center was approximately 10. There are some centers that had more than others. The maximum was 23 and the minimum was 6. Now, this is how we account for the cores at the National Cancer Institute with the P30 mechanism. We divide them into 7 categories: laboratory sciences, laboratory support, on down. As you would see, each one of these, if you go to the Office of Cancer Center website and click on shared resources, they'll give you an explanation. But when the Cancer Center submits the P30 application, they are asked to classify which category that their core falls into, along with the, the budget request and everything else. So, a little bit of an idea on what the distribution was within the cancer centers themselves. You see laboratory sciences at 52%. That's the majority of the cost for the cores themselves. In this particular, in 2011, the miscellaneous and unknown was 0, informatics 5%, et cetera. So you see, if we look at 2013, the laboratory science, and the laboratory science is generally the analytical aspects, any type of sequencing facility, it's all lumped into that. That has stayed pretty consistent. But the miscellaneous and the unknown has gone up considerably. And the informatics and biostatistics has also gone. The informatics and the biostatistics is key to the clinical and translational research. And the people, the clinicians that are doing the clinical trials, they do not have the expertise in these areas, or generally very few do. And so along with the core, it's a key point that you not only get the use of the facility, you get training at the cancer center, you also get a consultation with an expert that will help you actually go through the data and interpret it. So there's a lot of co-collaboration going on with the cores. Now, this map demonstrates the 68 cancer centers across the United States. They vary in size from extremely large to moderate in size. They all have the same mission. They want to cure cancer. Okay. What they want to do, though, is they first, with the CCHG, they want to look at the cancer in an area that is called their catchment area. Now, the catchment area I get a lot of questions about, and believe me, it is a geographic area. We do not dictate to the cancer center where it is. They tell us where their catchment area is. So, for example, one could be a geographic area of the entire state. It could be counties. It could be done by zip codes. But the reason why we look at that is we don't want a cancer center that specializes in something and ignores the patients that are coming through the front door of their hospital. So it's very important that they show that their research programs actually do work within their catchment area. Now, all that being said, they talk to one another. And there are times where they can't do something for a patient, and they will refer them to another. St. Jude's Children's Hospital actually has a catchment area of the entire United States. It's a little hard to justify, but they actually can do it. And they have not refused any child referrals from anyone, let alone another cancer center. Now, this is the FOA. It's PAR 13386. If you ever have a night where you're having trouble sleeping, I suggest you just read this over. There's an enormous amount of redundancy in it, but what it does do is it dictates exactly what the cancer centers need to put into the application. Now, it is done in an electronic form, and I need to comment that when it was a paper application, they generally ranged from 1,500 to 2,000 pages. Now it's considerably longer because it's online and we've saved paper. So now it's about 4,000 pages. Okay. But in that, all of those 6 essential characteristics, the shared resources, and everything is dictated in that. And along with that, you need to do an extensive budget for each one of the sections of the CCSG. And in the budget, there's a section called developmental funds. Now, this is how the NCI has addressed the need for the cores in the cancer centers. Since the cancer centers have cores that are funded, they need to be peer-reviewed before they can be funded. And so, and to be peer-reviewed, you generally need to have some background information. How successful was this core? You know, is it supplying the needs of the investigators, or the publications, et cetera? So to give them a chance of having a core without it being part of the original 5-year plan, we have developmental funds. And within the developmental funds, you can actually have a new shared resource, you know, which with having a recognized need. So you know what it is, you need it, you're going to take some of the developmental funds and devote it to this particular core. Then the next time you come up for a competing renewal, it would actually be part of the shared resources and cores. This is important because these developmental funds are restricted. They are only used for certain purposes. The shared resources or cores are one. Recruitment is another thing that it's used for, bringing in staff investigators, you know, giving them a little bit of seed money to get started. But it is at the discretion of the cancer center director that these funds only be used for these particular areas, and you cannot say, oh, one of my research programs is now in need, I'm going to take some of that money. So the first is the development of a new shared resource. That's important. The second thing is, and this has just come out with the 2013 FOA, is to increase the state-of-the-art technologies, you know, access to these and specialized shared resources through peer-reviewed sharing services with other NCI-designated cancer centers. So it's also written into the FOA that the cancer centers need now to interact, and this gives them a great opportunity to do it. And that is, if you have a shared resource at your center and you want to make it available to others, the other center can use the funds from the CCSG to purchase these. And so that has started. The benefits, besides, you know, the obvious of having better science and, you know, leading to a cure, is access to the state-of-the-art and expert staff and consultation services, development of standard operating procedures across the cancer centers themselves. You know, it's commented shared rather than duplicate reduces the cost. This is true, and equalizes the research field for all centers. This is something, if you're a small center and you don't have the ability to put in, you know, a mega sequencing facility, you can always use, you know, this particular source to find the answers through your research. And it increases the collaborations and the co-publications. Again, it's starting to get from a competitive to a collaborative environment. Now, some of the issues that come up, though, are the intellectual property. This is something that, you know, intellectual property, when it has to do with patents, it will follow the patent rules. And so what some cancer centers that have this is just in its infancy, started to do is they looked at what is it we can do. One is to use a non-royalty academic license agreement. This, you know, is something rather simple, and the Institutional lawyers don't seem to have too much of a problem with it. So it's just that you would sign this, and then they would do the work for you. You would get the results and take it from there. If it is going to be an invention sharing, if you think there's a possibility of that, it's always better to go with an MOA, which is a memorandum of agreement, or a memorandum of understanding beforehand. But these are some of the issues that are being worked out. The more cancer centers that do this, the more frequently it's used, the better it will be. Fees, this needs to be negotiated. And a lot of cancer centers are looking at, we'll charge you what you'll charge us. And so it's kind of a wash, so that they trade the actual technology. Quality assurance of the cores. There is a working group that's being organized at some cancer centers to ensure that there's the same procedure that's followed, the standard operating procedure, and so that the results that you have, will be, that are generated will be genuine and reproducible. And then, of course, always the protection of patient information. So, the website at the top is the Cancer Center website. It has a variety of information, including contact of my information, the staff, and also has the link to the shared resources. If you have a moment, do check it out. It's something that, it's informative as to what the National Institute of Cancer looks for in the CCSG shared resources. And I'll take any questions if you'd like. But thank you.
Okay, we're going to get started with the panel discussion. We have Sally Rocky is still on the phone with us. We have Joe Ellis, who you heard a little bit before. Joe is also from the Office of Extramural Research. Todd Wilson and Michael Marino from NCATS and the Cancer Center. We also have with us Christopher Sanford from the National Science Foundation. And he won't be presenting, but we've found that there's some overlap in support and technologies for cores with NIH and NSF, and we asked him to be here partly to get your views, but also for us to start learning how to work better with NSF. So I'll open it up. We have about a half an hour, and again, this is an opportunity to ask specific questions about NIH policies, procedures, but also offer your ideas about what NIH can do to help make things more efficient.
Dave Gornstein from University of Texas. NCRR used to support a wide range of shared local, regional, or national facilities, NMRs, and so on. And that was pretty much abolished. There's still, within some of the different ICs, some of the programs that are regional facilities or national facilities, but there's been backing off. So we've actually gone the opposite direction from what you're asking us to do now. Do you want to comment on that?
Going the opposite direction as far as the use or funding specifically,
well,
funding the cores?
You want to see us working together, sharing cores and everything.
Correct.
But the original framework for that were the shared, I used to run a NMR national shared facility at Purdue, and I know that those programs pretty much have been.
We clearly, as you're pointing out, we can't fund full networks of cores. I think what I do want to emphasize, and that last slide was part of that, was the innovation side of this, that you can make impacts in the way we provide services, provide cores, provide the business models. Those are shared, those are clearly things we can share without having to necessarily fund the infrastructure. And I think that's the innovation that we're talking about here, and those are the kind of inroads that we'd like to make.
It looks like you're not looking for, in the new 2.0, if you will, a version of the original NCRR type of shared cores.
Correct.
So Jim Cherry, Scientific Program Director at the NCI Frederick for the National Lab. So what is the NIH's position on allowing these individuals to partner with, or to the actual, because you know the NCI Frederick, the National Lab, has the contract creator authority to partner with the core laboratories up there? I mean, from genomics, imaging, informatics, what's your stance on that?
Are you talking about sharing intramural and extramural?
I'm saying allowing these individuals to be able to access the utilization of the cutting-edge technologies that are up in the Frederick campus.
So again, you're talking about extramural investigators making use of intramural. Okay, I'm going to ask Sally or Joe to address it.
Okay.
It is something we deal with because it's two separate appropriations.
Yes.
And we can't let one support the other legally. So, but
Well, but with the Congress's authority allowing the national lab to do that now, which happened just a year ago, how's that changed?
let's see if Joe can address that.
Yeah, Sally might want to jump in. We've been looking somewhat at NIH to permit use of intramural facilities. Right now, there's a program, a UO1 program, when there's a shared research objective and shared research between an intramural investigator and an extramural investigator, that investigators can get access to resources at the clinical center, which isn't the Frederick facility, but we've been looking at that, and we may be able to expand that over time. There's been some limitations in NIH's authority, and I'm not a lawyer, so I can't explain all those, that have prevented that in the past.
Right. So we have a program with the clinical center whereby there's actually grants made to extramural investigators who have a collaboration with an intramural investigator who are using resources at the clinical center. And the money then is made through is distributed in three ways. It's distributed to the extramural grantee in the form of a grant, the intramural collaborator through their own intramural laboratory, and then a piece goes to the clinical center for the resources that they're going to use. So there are ways to do it. If we wanted to specifically talk about Frederick or some other way, we'd have to take a look at the specifics of what is desired and how we might do that. But we are trying to promote the idea of the entire scientific community, including the intramural and the extramural, together to be able to take advantages of NIH resources.
So we are funded out of Dr. Varmus's office, and so we have two partnerships in place, one with the University of Maryland, Baltimore Medical School with Nick Ambulos, as well as with Hopkins at APL from an informatics standpoint, as well as next generation sequencing. So it's definitely something that, so the money wouldn't be coming to our office, but it allows them to utilize the services and they get charged back for those services that are being utilized. So it's just something to think about.
So can I just rephrase that? So the general suggestion you're making is to find ways that intra and extramural can share core resources.
Correct.
Okay.
Correct.
Please.
Brad Cairns from the University of Utah. So first of all, Michael and Todd, thanks for your presentations. And the fact that you're sitting next to each other in this panel is perfect for the question I have. So I think cancer centers and CTSAs, many of them are at the same institutions, and sometimes they have overlapping core facility needs. And I'm wondering what the two of you might be thinking about ways that coordination could happen better, where you could have core facilities that would cross both of them, how that could be incentivized by the NCI and the NIH.
You want to flip for it? Yeah.
Actually, we just met today. No, no, that is something to be considered. You know, with the coordinations of the CTSA and the CCSG.
Yeah.
Yeah.
I mean,
I would echo that.
Yeah. I mean, the use of the cores, it overlaps along with the clinical research. So, yeah, there is a strong core between us, or bond between us.
I've already asked Mike to sit down and drink some coffee together and talk about these kind of things. So that's.
I think biorepositories and the informatics that connects them is a real opportunity, especially to do that. We're trying to do that at Utah now with sort of independent resources, putting them together. And then also, if you really want to emphasize it, you can make it part of the grant renewal criteria, is that will be recognized on the backside.
That's true.
Yeah. So this falls in the Willie Sutton recommendations, is go where the money is. And so this is a good idea. Thanks. So these are our two largest organized grant supporters, core supporters.
Hi, Lauren Becknell from the Duncan Cancer Center at Baylor College of Medicine. I have a question that actually piggybacks off of Brad's. So kind of continuing to think about collaboration and centralization of cores and shared resources. One of the things that the NIH is doing through its Big Data to Knowledge program is thinking a lot about resource or research object identifiers. They're not the only group that's thinking about this, but I wonder if kind of thinking about tracking of cores and shared resource utilization and funding, and how the same core may be called different things on 4 different grants from 4 different institutions. Is there thought to implementation of some sort of a core identifier that could be used with grants, specifically that could be pulled pretty easily through electronic processing of SF424s?
That's probably Sally.
Yeah.
Is anyone talking?
We're waiting for you, Sally.
Okay. No, I think that's a great idea. We've talked about it before because one of the issues has been we oftentimes can identify a core if it's in the main project, but if it's in a sub-project, it becomes even more difficult. So something like that, and Joe may be able to elaborate a little bit more in depth, but something like that of tracking, a way of tracking it and having some sort of system to be able to do it. And that also would be helpful when core facilities are cited and paid for in part by R01 grants.
And who is that? Who is it used by? So I can see that'd be very useful for NIH staff. Are you suggesting this is a way to nationally advertise cores?
I think it could be. So it could obviously be NIH. It also could be something that our customers could use to unambiguously cite us. Not even just mentioning our names and publications, I think, is a challenge. But maybe that would help to present unambiguously which core they're citing, because most of us have 20% funding from any one grant, even larger grants like the CCSGs or CTSAs. And so when you're funded by 25 different grants, they might refer to my core by 7 different names. But we're the same personnel, we have the same mission. I see us as one core, so I think there could potentially be lots of different users. Also, I think you mentioned in your CTSA presentation, Eagle Eye. That's not the only resource of its kind. So those sorts, maybe a core, if we're a resource object, so a core research object identifier could also be utilized by indexing services, such as Eagle Eye, or eventually the Data Discovery Index, Software Discovery Index, Core Discovery Index that NIH may put together.
Absolutely agree. It was only put up as an example to exemplify the need. That's all.
Thank you.
Yeah, I was wondering if there was something that we could do in indexing, you know, the syntax and how we would put it together might be very meaningful, because you can imagine that you could have some sort of structure to how you would index things based on even the resources that are available. So it makes it easy to find, even easier to find.
Jean Schaefer. I direct the NIDDK-funded P30 for the Diabetes Research Center at Washington University. And my question really stems from what's been my experience for the NIDDK P30s and the changeover to the reporting of publications that cite the cores. So we've, I think, and as many of the other centers have encountered, a fair administrative burden in terms of trying to assure compliance of publications. And all of those of us who direct centers are also on the line for our own grant funding if there is a single publication by any user anywhere of your center that is non-compliant. So while collaboration across centers and outside users is a great idea, do you have any thoughts about how we're going to tackle this problem as we move forward? And I assume this is a big problem for the CTSAs as well.
So you're talking about the public access policy?
Right, right. So the grant is
Yeah,
held
so
up.
you know we put out a notice to help you all. We know that you want to take credit for the accomplishments and the publications that arise from cores, but there's 2 different sections in which you put the publications, and one is what you're responsible for as far as public access, and we've changed that now so that you do not have to be responsible for the compliance of all of the publications that arise from the cores. So we put out a note, I think about 3 or 4 months ago, to try to clarify that, to make it easier on you all to comply with public access.
Thank you.
And I can make sure you're get a copy of that if you're not aware of it.
Hi, I'm Katia Solchor from the AI DuPont Hospital for Children in Delaware. So when I say Delaware, I'm going to bring up the IDEA program. And a question for you, Todd. You talk about sharing. You know, it was a great presentation. Can you start sharing now? When you were talking about, you know, you guys worked on the formalizing and standardization of the evaluation process. Yeah. As part of the IDEA program for the Northeast, we have a memorandum of understanding among the 5 IMBRE states, IDEA states. And we started a subcommittee working on that to demonstrate that we can do it. We don't want to reinvent the wheel. If you guys have already some stuff that you could share with us, I realize this is, you know, same program at the NIH. I mean, it's sub-programs, but they're all about research sharing. So that's my first question.
Thank you, and I absolutely would welcome that. We understand that the metrics that we develop or evaluation standards that we develop may be similar or used by others as well, and our goal isn't to reinvent the wheel here. I mean, it's never our goal to reinvent the wheel, yes. And it's also focused around team science and collaboration, yeah. So thank you. Yeah.
And again, you're the focus of my attention today.
Oh, no.
Talk about CTSA, how about CTR, talking about sharing, you know, the NCATs and the general, you know, the NIGMS, which house, you know, the CTRs.
Yeah.
Again, it's an IDEA program.
IDEA program that we could, yeah. I think there's room for collaboration. I think we need to have these discussions. There's a lot of stakeholders that we engage with, and I should say that on most of these efforts that we put together, we also involve patient groups and other groups as well to participate on this and get their voice. So we are open to this. Okay.
Is there any way that I can maybe talk to the PIs of this CTR in Delaware and see how, you know, I'm all for, you know, speeding up processes like that when I see that there's opportunities.
Why don't we talk offline after,
okay, cool.
We chat.
All right, thank you.
Hi, George Gross from Cornell. So I have a comment and a question. The comment is in terms of the excellent suggestion before about having an identifying national number for each of the different cores. It'd be nice if that was also annotated to indicate which core center they're involved with, because it's very difficult sometimes to know the difference between what individual cores are doing and what a whole center is actually doing. And that would really help in terms of tracking that, knowing how many centers, the centralized core centers there are, and what their activities actually are. My question or suggestion would be in terms of helping to encourage folks to use cores and to help help tracking of those use of cores. My suggestion is that for R01 grants, they include a section about you know, what is the potential use of the cores, and in the progress reports, in some structured way to indicate whether or not the cores have actually been used, so that over time you can actually help track what these research grants are actually utilizing in terms of shared research resources. And I suppose my final question is just, you know, I had indicated before, you know, a question about what's the best way perhaps to create databases of cores and surveys of cores, and I was wondering maybe if you could, you know, comment a little bit on that.
Well, others can join. I guess the question is, why would you create a database? You would do it so that others are aware that you have a core you're willing to share. So there are some, for example, institutional cores that are not ready to share or willing to share with others. So there are definitely cores that are not, that you wouldn't want to list. I think my own experience is that there are cores that aren't, that don't make sharing a priority. So you'd first have to make it a priority before you'd want them on the shared list. And then there are high priority cores for people that, you know, that are more unique or highly specialized. I'll just pick mass spec or something like that. So I don't personally think a national database of every core is the goal. There has to be some thinking of what do you really want to put in it and how do you compel people to list it. And I don't have an answer to that.
I mean, I understand your perspective on that. I have a slightly different perspective. I think it's very useful for an institution to be able to list their own cores on a national database, because it's very difficult for them to know if they're, you know, what they actually, within an institution itself, sometimes even within a building, investigators are not aware of the cores or shared resources that are available. To have some type of structured way that you could just tell an investigator, go to this database, it'll tell you everything that it's at Cornell or Vanderbilt or wherever, it would be very useful. And you could also look at what your neighboring institution has as well, and whether or not they're willing to share those resources. So I think it's a very good regional resource, as well as a local, regional, as well as a national type of resource.
One question I'd have about that is that since NIH doesn't support all cores, would it be better to have that done on a national basis that NIH might piggyback onto, rather than just have the NIH develop a system for indexing these and tracking cores and what's available for sharing? And that would work well when there's other agencies involved as well.
My suggestion would actually be similar to the way Eagle Eye was actually developed. If there was some funding opportunity to create the nucleus of this, because it's really the development work that's the major cost, and you know, have the community determine what might be the best mechanism to move forward. You know, I know that certainly the ABRF has been involved in trying to create a database of cores and VGN, and as well as Eagle Eye. There's a lot of players in the field, and even having, you know, an inducement for collaboration between all these expert players might be a good way to move forward. So it's really having the NIH plus perhaps the other funding agencies like the NSF and various other ones that might be interested to create perhaps a joint funding opportunity to move forward with this. Thanks.
Yeah, just to follow up on a comment on that, what we stumble over in terms of shared cores regionally between institutions is internal versus external rates. And PIs at one university don't want to pay the external rates at the other university. And then it goes up to high-level discussions that never get solved. And so then we build our own cores.
To give one example, in Chicago, we've done a core coordination. So we have the 3 major universities signed agreements at the president level, and one of the ways we were able to do that was to get an external survey done, study that we could then hand each of our top administrators and say, you know, this is something that would be highly efficient. It would save money over time, and as soon as you say save money. And then to justify it, we did metrics on how much was going across from one to the other, and can show that more or less it was equal coming and going, not in the one core, but institution-wide. So you could say one institution is not losing their indirect costs, it's a wash.
Can I, before we go on, Julie, can I ask Joe, is there anything NIH is doing or not doing that can help?
Well, there's nothing that NIH is specifically doing to encourage that type of an agreement, but that's actually an excellent idea for institutions to work together to minimize the cost of such sharing and do it in an efficient way. And generally with indirect costs, the differences work out to be fairly minor. And that type of approach on a regional basis, I think, is a good idea, to try to share this and not to get caught in the details and trying to charge higher costs to institutions just because they're external. There's no requirement in federal cost principles or NIH policy to do so.
So I just want to make shift the topic just a little bit so that Chris's effort at coming to St. Louis does not go, is not wasted. I'm Julie Auger, currently now at University of California, Davis. I spent a lot of time in biomedical institutions, so I don't have a lot of experience with the NSF programs. But at Davis, there is a lot of NSF-funded core facilities that span a lot of different disciplines. And I'm really curious as to how much integration and cooperation there is across agencies between the NSF, the NIH, in terms of sharing facilities, sharing user bases. Are there differing policies that would prohibit use of facilities or instrumentation that's funded by the NSF within other disciplines?
Well, that's actually why I'm here, is to sort of see how we can maybe facilitate some of the efforts rather than duplicating things. So that's precisely why I'm here.
Part of the experience that I've had at the primarily biomedical institutions is when we did apply for NSF funding, we always felt that there was a need to kind of make sure we couched it in non-biomedical terms, right? Because that's a requirement of the NSF, which is a challenge for a highly biomedically focused institution. And so I'd like to see that there's some sort of coordination so that we don't feel like we're trying to always fly under the radar, but that there's some open dialogue across the NSF and the NIH, that sharing of these types of resources and co-investment of these types of resources are actually a benefit. And I think that would be terrific.
I agree.
I'd like to just mention that we have a federal-wide group called the Research Business Models that's co-chaired by NSF and NIH, and I'm the co-chair for NIH. And this is comprised of 14 different agencies, all of whom fund research. And one of our tasks that we've been working on over the past year, not specifically cores, but instrumentation, but it pertains also to cores, and how we can make sure that the federal-wide policy facilitates sharing. And so oftentimes what it is to understand this is just to make sure that the guidance from OMB is clear and that there's a clear interpretation of how sharing can be done. So we've put out a couple of notices just about clarifying what is allowed and what is not allowed under sharing. But yours is more at a philosophical level. I think your question is of how we can talk to each other in order to share ideas that may fall under each of our joint goals, and then consequently share resources that are part of that.
Yeah, and Sally, this is Julie again. I just want to say that it is a philosophical, but it actually speaks to what Jim mentioned earlier, is this cultural change that has to happen at institutions, or funding agencies. So it's not just putting mechanisms into place, but it's actually how do we change the culture of what we do. And so
right.
it is.
And I think that starts with us to make sure we communicate to the university so there's not a misinterpretation of our rules and regulations. This has happened on a number of occasions where institutions interpret things differently than what was actually the intent of our policies or our regulations. And so if there's specific things beyond the shifting of the culture, which is very, very important, as you point out, if there's things that are actually hindering this kind of sharing of facilities or cores, that we could clarify, we'd like to know about that. So that might be a little piece of homework I'd ask all of you to think about, is just if there's things that the universities and or your departments and or your cores would like clarification at the federal level about rules and regulations, we'll be happy to do that.
And I think I just want to add, Julie, this, if everybody's budget were still growing, it wouldn't be an issue. Right. I recently met with leadership of NSF to set up points of contact in different fields where we can talk to each other more effectively than we have in the past. So there's cultural change needed, yes.
Okay, I'm Larry Marnett from Vanderbilt, and I'd like to go back to the question of listing, or the issue of listing cores so that individuals around the country can be aware of them and have access to them. I'm glad Todd showed the slide about the CTSA catalog of HTS facilities. That was a particularly good example. But if you look, there are probably 35 HTS facilities. And I could probably assure you that they vary anything from a single investigator with one robot to a very sophisticated facility that has very deep capabilities. And so quality across the listings of these facilities is something that is a second level of information that's, you know, you'd sort of like to have TripAdvisor for cores. And that's much, much harder to do. So I think it forces you to be very granular in the listing about what the cores do. So Bill, you know, you said that you have this sort of cooperation in Chicago. So how detailed do you get in the listings of what each of the core facilities do so that an investigator at least can say, well, if they do this, maybe they do it pretty well, and do you have a reference list of people that have used the cores that have been happy with it? Right?
Yeah, well, we rely on so we have a master list, and then from that master list, you would go to the institution, which would have a detailed web page for each core. But in terms of your last comment, no, we don't have a TripAdvisor or a Yelp. So that's certainly something that we've talked about a lot, but it gets very sticky in terms of rating cores. But that certainly is, I mean, a publication list is one way to do it without being quite so judgmental. You can see what publications have come out of that core.
And you know, it sounds like a great idea, but if it's not accurate, if it's not up to date, it's useless, and it's not helping. And I don't know how to do it. Why don't we take 2 more questions and we'll go on to the next sessions.
Okay, so I'm Andy Chitty. I'm from Oregon Health Science University. And I was thinking, as you were talking, Dr. Anderson, about the funding for consolidation of cores. And one of the things that was going through my mind is if you're looking for ways to potentially, for that to cost less to the NIH, is you might think about a certain fraction of that cost. For example, sort of a matching, like 90% from NIH, 10% from the university or something like that. The reason why I mention that is because I kind of think that if the universities, if there's that carrot out there to go and get some of that money, but they also have to have a little skin in the game at the same time, it might rally them together a little bit to think very carefully about what their strategic policies are for cores and for consolidation and what's going to work very well. Perhaps that's something that's already being done, so I'm just curious. As to
it isn't done. There's no grant or supplement follow-up to that ERA experiment, but if any of you receive those, I'd be curious to know what made the most difference, because some of these one was $1.3 million, but was it $100,000 that made all the difference? In terms of the efficiency and so on. We don't have that type of resolution on what made a difference. How about one more?
Okay, I'm Ron Neese, and not currently affiliated with any particular institution, but as a part of the membership committee for ABRF, we would like access to that listing of all core facilities. We know there are lots of institutions that have core facilities, but no ABRF members, and we would like to recruit them, but we'd also like to help them bringing what we are bringing to them here at this meeting. So we look forward to such a listing.
I should say Ron was a founder of the ABRF and is still looking out for us. So.
All right, thank you for your ideas. I'm going to hand it over to Bill.
Schedule. The cookies and coffee were paid for by the ABRF, not NIH.